These notes are over section 3.2, gravity. Okay, so for the law of gravitation, anything that has mass is attracted by the force of gravity. Okay, so for example, you have mass, and so you experience gravity, and we generally, whenever we think of gravity, we think of Earth's gravity acting upon us. Okay, but in order for gravity to be applied, it's between any two masses. So these two masses, or two objects basically, exert an attractive force on each other. Okay, so the force of attraction depends on two main things. One, the mass of the objects, okay, and two, the distance between those objects. So we don't notice gravitational force between small objects just because the force is weak. So if you think again about Earth, okay, we feel the gravitational pull of Earth. So whenever we like jump up into the air, we feel it pull us back down to Earth. Okay, otherwise, if there was no gravitational attraction, we would just stay floating above Earth's surface. Okay, so we get pulled back down. Okay, and so if you think about the moon, when people jump on the moon, if you've seen like the astronauts doing the moon, like jumping along the moon, okay, they stay away from the surface longer than they do here on Earth. Okay, and the reason for that is because it has less gravitational attraction. Okay, and that's because the mass of the moon is less than the mass of the Earth. So because Earth has a greater mass, it has a greater gravitational attraction. Okay, and then also it's the distance between those objects too. Okay, so when we're on the moon, we're not going to feel the gravitational pull that the Earth would apply to us. Okay. And so when we say jump from the Earth, we actually have a gravitational pull on the Earth as well, okay, because both masses have that attraction. But because we are so small when it comes to the size of the Earth isn't moved towards us, okay? We can't notice any change. It's such a small, insignificant amount of force there, okay? For gravity, it is an acceleration, so the units for it is meters per second squared. And on Earth, the acceleration of gravity is 9.8 meters per second squared. Generally, if you ever have like math problems when it talks about gravity, usually we denote it with a negative sign because it's pulling us downward. Okay? So weight is just the gravitational force exerted on an object. Okay, so that's different than mass. So mass is the amount of matter in an object. So if I am looking at my mass, I'm going to have the same amount of mass on the Earth that I do on the moon. Okay, unless I chop off my arm, I'm going to have the same amount of matter that makes up my person. Okay. Compared to weight, I'm going to weigh differently on the two different surfaces because of the amount of gravity pulling me downwards. Okay, so because Earth has more mass, it's going to have greater gravitational pull. I'm going to weigh more on Earth than if I were to take my weight on the moon. Okay. You can experience different gravitational pulls here on Earth. Okay, they're going to be slight. They're not going to be as great as we see on the moon. But at the top, at a very peak of the mountaintop, compared to below ground in a mine shaft, there is a change in weight. Okay, so our mass is not going to change, okay, unless there is matter added or taken away from that object, but the weight would change. So at the top of the mountain, it would have less gravity because it's further from the center of mass of Earth compared to the mine shaft, which is underground. It's much closer to the center mass of Earth. Okay, and so here is the equation for finding weight. So it's mass times gravitational strength. So the gravitational strength is always going to be 9.8 meters per second squared. Well, if you're speaking on Earth. If we were on a different planet or on the moon, it would have a different gravitational strength.